All right, so this is basically the next chapter is chapter 5. And what I want to do conveniently for you guys is just go ahead and get straight to the point. We're dealing with normal distributions now. And if you remember correctly, from the empirical rule, I don't even have to draw that. Let me go ahead and make this a little bit thicker. So if you have a graph here, it looks like this. That's a bell-shaped curve. Zoom out over here. It's a bell shape. Not all bell shapes are normal, but it's just if you're normal, you're bell shaped. And one of the principles of a normal distribution is that here's the mean, which is equal to the median, which is equal to the mode. And because of symmetry, you can imagine that both sides are a reflection of each other. Okay? So that's pretty straightforward. The area under the whole curve, the area for the whole curve is equal to 1. So if you were to shade this and figure out that area, it would be 1, which makes sense because 100% of the area is in decimal form is just 1. Okay. Now, I'm not utilizing space very well there, so let me see if I can fix that a little bit for the notes because I'm going to post notes on there. So the mean equals the median, which equals the mode. Right? That's this. And this is a normal curve, which describes a normal distribution. Now, here's our main problem. See, right here, let's say the mean here is 20, and you have this distribution. And let's say it's normal. It has a mean of 20. Let me go ahead and let's say it has a sigma, I don't know, a sigma, a standard deviation of 1. So then this point here will be 21 and this one here will be 19. Okay. But you could also have another distribution, another normal distribution. Over here at 25. And now this sigma is a sigma of 2. Now, this might not be perfectly to scale. It might be really bad. But let's just pretend this is over here. This is really bad. It's 23, 27. I should have slid it over a little bit more. You know what? I can do it because I can just quickly erase. So this is 22. This is 23. This is 24. This is 25. This is 26. This is 27. And so I need to make sure something like that. Not the best. Oh my gosh, that was horrible. Okay, so we have a mean here of 25. So that's the mean. We have a sigma of 2, which is not the best drawing there. Not the best drawing there. Let me fix that part there. Because there's something important about it. So right here, at 1 standard deviation away from the mean, we call these inflection points, by the way. Inflection points always occur. Let me fix that. at 1 sigma from the mean. Okay. But now, here's what's interesting. Here's what's even more interesting here. Well, it's not too interesting, but something you should know. See, the mean here was 20. The mean here was 25. So you have two normal curves there with one mean and another with another mean. And then you have each of them have a different sigma. So you notice that the one in purple has a bigger mean. And it also has a bigger standard deviation. Now, I could have changed the position of the first one there that has a mean of 20 and a sigma of 1. Notice that what the sigma does is it changes how wide or narrow the data is, or basically it's the spread of the data. Okay. So that's what, give me 1 second. La multivariable. La variable, no sé si puedes por todo esto, es la genitud. Las tres caballos, variables. No sé si eso se llama. Eso es Teliflow, pero. No sé si lo más todo igual. One second, let me just pause the recording because I have to send a document. Recording. All right, so what I want you to realize is that there's an infinite amount of normal curves. There's an infinite amount of normal curves. And we want to be able to figure out the areas because the areas associated with those normal curves is the probability. So let me give you an example. Let me go ahead and increase the thickness of this pen. And it is recording. So here we have this normal curve here. It has a mean of 2. A mean equals to 2. And a sigma, I don't know, of 1. So here at 1 sigma, the inflection points, it'd be 3. At the next sigma, it'd be 4. If we go in the opposite direction, it'd be 1 and it'd be 0. Now, what I want you to realize is, let's say I'm interested in this area here. All right. From 2 sigma this way. Right? Then let's say I look at another distribution. This other distribution, you know what, it doesn't matter. I'll draw whatever. So the mean here is 20. And the sigma here is 4. So it's a completely different distribution. So at 1 sigma, what would be the value here at 1 sigma? What would be the value for x at 1 sigma? What's sigma here equal to? Sigma equals to 4. What's 20 plus 4? How about at 2 sigma? 28. And how about 20 minus 4? 16 minus 4. So this is -1 sigma, this is -2 sigma. Now, I tell you that, let's say I'm interested in finding the area from 2 sigma back. What if I told you that both of these areas, even though they're different normal distributions, they have to be the same? It can be shown that they are the same. This is the key here. That those two areas would be the same from 2 sigma back. In fact, they're all the same. So like, let's say I wanted to figure out, instead of from 4 to the left or 28 to the left, I would say, okay, let's figure out from 3 under and 24 under, 1 sigma and 1 sigma under, or to the right, doesn't matter. The whole point is they are the same. Why am I telling you this? Why am I going through the trouble of telling you this? Well, because if these are the same, then what if I wrote this one here? Okay, this one here, this has a mean of 0 and a sigma of 1, right? And let's say this is the inflection point here. So what would this value be here? For those of you who are interested in participating. You guys are so undermotivated. 1, yeah, 1. And the next one is 2. And how about over here? What's going to be? And this would be? Okay. You know what? If I shade this area here from 2 back, wouldn't it also be the same as this and this? Wouldn't they be the same? But this guy here, we call the standard normal distribution. And we can use this distribution who has a mean of 0 and a sigma of 1 to judge all the other areas of every single normal curve. Now you got to remember there was a time when people didn't have calculators that can easily compute the areas. We have calculators now that can easily compute the areas for any mean or any sigma that you want. I saw Emily pass by and she didn't come into class. Can you believe that? She passed by. I saw her from the side of my eye. Anyways, now that comes on the recording. All right, so why do we worry about this? Because before we had these calculators, we had just a chart, and that chart just was for the standard normal distribution. And what we did is we standardized.
Good morning, gladiators. Excuse the interruption. Teachers, at this time, please will you stop scheduled to take the Algebra 1 basic exam. A list of all test results this morning. Select gladiators.
So what we did is we converted the X score into a Z score. So it's standardized that way. In other words, we said, okay, if we just realize that from 2 back, what is 2? Well, in this case, 2 is 2 standard deviations away. And in this case here, 4 is 2 standard deviations away. In this case, 28 is 2 standard deviations away. So all we had to do is apply a formula. And what we were supposed to do is we're supposed to use the formula that says Z equals X minus mu divided by sigma. Remember, this is called a Z score. So our hope, not only our hope, is what we're going to do is we're going to transform a normal distribution to a standard normal distribution by applying a Z score. Now, in theory, if you did every single score that you had from the normal distribution and you applied a Z score to it, you end up with a standard normal distribution. But we're not going to do that. We're going to pick a particular score and convert it to a Z score so that we can reference it to the standard normal distribution chart, and that references the area for the initial distribution. That's what we're aiming to do. Okay, so it'll be something like this, and you'll start with something like this, and I'll make sure you guys see it. So you start with something like this. Mean is 30, sigma is 3, and let's say this is 35, and I'm interested in this area. Let's just say. So you'll start with something like that, right? And I'm like, I want that area. Why? Because our area is really the probability of that particular score being less than 35, because we're shading to the left. And so what you would do is you say, okay, fine. I'm going to apply this to a Z score. 35 minus 30 divided by 3. That's 5 divided by 3. That is in decimal form. 5 divided by 3 equals 1.67. So we have 1.67. Okay. And that means that this here, that area there is equivalent to as if I did a mean of 0, sigma of 1, That's a standard normal distribution. Where this here is 1.67. And we find this area. And we need a chart for that. Now, you don't have the charts. I'll print them out for you. I've already put it on Teams, so please print them out at home, double-sided. This shape is so important that it is the whole point of the book, in my opinion. Chapters 5, 6, and 7 are the reason to be taking this class. All the stuff we've done before is important, but this is the reason. So when you take this in college, by the 3rd week or 4th week of the course, remember there's probably like 10 weeks in total or 12, depending on the college you go to. You'll do everything we've done this year in 3 months compressed time. So this is the whole point of this class, right? So if you're gonna not learn anything, it's not this. You gotta learn it. You're gonna take this in stats, you're gonna be just fine. Some of you are just so, I don't know why you're so undermotivated. Why? Okay, so here's the thing. How do we get this area here? How do we get this area? Well, it's super simple. You got to use a table. All right. So I'm going to go ahead and show the table on the board, and I'm going to try to show it here on this screen so that if you need the video, you see it. So what is the Z-score we got here? By the way, this is a Z-score. That's a Z-score. The Z-score is 1.67, correct? So now you need this table. If it comes up, you need this table. Now let me go ahead and put it here too. So I'm going to stop this share. I can share just a desktop. Let me see if it works. If it doesn't work, it doesn't work. So screen whiteboard. You know what? I'm not going to risk it. I'm not going to risk it here. So I'm going to just go straight to the, all right. So in this case, what was the Z-score? 1.67. Now notice how it reads it. It says whatever Z-score you get there, its area is going to be to the left. The area that this is going to give you is to the left, right? So we go here and we find, and I'm going to go do it here. We find 1.6 here on the side. Here's 1.6. You see that? Let me make a note here so everybody sees it. So we go down to 1.6. All right. And now the first one is 1.60, 1.61, 1.62, 1.63, 1.64, 1.65, 1.66, 1.67. So it's 0.9525. It's 0.9525. That indicates the area to the left of that particular Z-score. Okay, so let me stop the share here. And wow, my face is ugly. So let's go back to this. So it's 0.9. Remember the number 0.9525? Is that what I said? Yeah. 0.9525. So that means that this area here, using the table, is 0.9525. And guess what? That means that this area over here also has to be 0.9525. And this is from the table, the standard normal distribution table. So as long as you know how to use that table, you can do every single problem. Now, what do I recommend? I will have the copies for people who didn't make the copies. Hopefully, by the time I'm done with this lecture, you'll be able to do the homework if you print out your table. And next class, we'll be continuing that homework because there's a few problems there. And I'll make sure that I'm giving you ample time, if you didn't do it, to learn it and turn it in for a grade, everybody. So this is a grade next class, that homework assignment. I'll put in a grade for that. And then we'll test on it after you've done the assignment, after we've worked on it. Fair enough? And hopefully you show up to class to take the exam. We must do our best. Okay, so Quick question though. What if what if I'm not interested in this area? I'm interested here. What do I do if I want that? If I want that area, what should I do? What's the area under the whole curve? What do we say the area for the whole curve was? Simple number. What is it? 1. So if I want to figure out to the right of that, and I know to the left is 0.9525, what would I do? I would take what? 1 minus 0.9525. And what's that, by the way? Just so I have a complete note. 1 minus 0.9525. Well, that's 0.0475. So you can, if you need to figure out an area to the left, and let's just make a few quick notes. So if the area is to the left, they also like to use the word cumulative. You just read it from the table. And then I should really put if here. Now, if area is to the right, then we take 1 minus area to left, which is on the table. Remember, the total area under the curve, in fact, under any, see, a normal distribution, they call it a density curve. All density curves have an area of 1. Oh, David's asleep, man. What time you go to sleep? In the morning or at night? 7:30? Okay, so that's a little bit on the late side. Yeah, I went to sleep at 9:30. What does Benjamin Franklin say in the almanac thing? Early to bed, early to rise, makes a man healthy, wealthy, and wise. Haven't you heard that before? My gosh, you guys are not being taught anything of value. Haven't anybody up here started looking into Stoicism? None of you are working out in the morning? None of you have bought a Microsoft Surface? No. The reason you work out early is because you want to conquer the morning. You don't want to live a life of luxury. You want to live a life of challenge. If you're excited enough about life, you'll be awake early in the morning. It's a miracle. It's not boring. Right now, this instance will never happen again. It is a wonder and a miracle. Did you know that? You don't believe that. I do. So think about that for a second. Good morning. For today's vote, please remember the following. Page 1. Oh, we're going to do a vote for the union. Okay. Think about it. It is a miracle. You just don't see it that way. You think it's not boring. It's a wonder. It's a change of perspective. One values every second. The other one pretends like you have all eternity. And you're not. You don't have eternity. You don't know that. And 80 years is not a lot. Ask my dad. My dad's 84. 80 years is not a lot, especially when you spend about 20 of those years in rapid decay. This is a miracle. You just don't see it that way. And one day we'll be gone. All right. Anyways, so we have one more little situation. And I think I should explain it a little bit to the side. Anyways, I don't know. You guys are really quiet. Does it look like I'm excited at least while teaching this? No, is my voice monotone or something? What do you mean? It's normal. Okay. I have to pee too. All right, so let's go over here. I drank a lot of water this morning. What happens if I want to figure out the area in between? Like, what if instead I want to, you guys, listen, I want the area between 1.67 and I don't know, -1. In other words, I want this piece here. How would we figure that out? Any ideas? Any ideas? Well, look at this. If we figured out the area to the left of 1.67, it would be 0.9525. That's for sure. If we figured out the area to the left of -1.0, and I'm gonna cheat a little bit. I have the chart open. I think I remember what it is, but I'm not gonna trust myself. Where's the thingy here? Yes. Be careful. I mean, I should give you a pass. Take the pass if you see it up there. All right, just try your best. I think I closed out the document by mistake, but anyways, I have it up here. No, I have it. Do I have it here? No, I don't. Of course not, because that would be awesome. All right, so if we come here to the table and we look up 1.0, it says 0.8413. So the area to the left of -1.0 is going to be, actually, it's -1.0. Go up. Is it here? Up. It's loading. So the area of -1.0, when it loads, of course. Come on, computer. Why doesn't it pop up? It doesn't matter. It doesn't want to pop up. All right, so I'll just open it here. So let me stop the share. And go ahead, go here. No. Okay. Just minimize for a second. Go here. Go here. I have a bazillion things. There it is. Why didn't it come out? Okay, so I'm gonna share. So share, come on, where's my Zoom thing? My Zoom thing has disappeared because that's how it always is. I'm gonna share. Share screen. I'm gonna go ahead and share this. Now you're not gonna see it, but I'm gonna go ahead and tell you that -1.0 is 0.1587, but it would really be nice if you could see it. Let me see if I can get you guys to see it. So new share. I don't know why this is not loading properly. Let's go back. And let's open it up again. That's the table that you need to print out when it loads. Come on. And so I want you to see the same thing I'm seeing because it's important. Now the positive z-score table came out and here's the negative. Okay, so now when you do the negative z-score, you got to realize that when you find -1.0 here, this first one here is not -1.00, it's -1.09. You see? So if you come down here to -1.0, this first one here is not -1.00, it's -1.09 because it does it backwards. So -1.09876543210. The answer is 0.1587. 0.1587. So the answer is back here. And this has to do with the way they do the normal distribution tables for the negative one. They don't start up here with 0.00, they start here with 0.09. Notice that in the positive z-score table, it starts with 0.00, ends at 0.09. So we look at positive z-squared things. You have 0, all the way to 0.9. It's backwards. And a lot of kids forget that, and they're taking their quiz or their test, and they know what they're doing, but they were just not, they were not being careful. So it said 0.1587. I commit that to memory. Then we go do a new share, and I'm gonna go to the Microsoft whiteboard. I could just do my main screen. You know what? Let me test my main screen. So it's always gonna be on the screen I'm at. And then I can do the Zoom meeting up here and then just simplify my life. But I'll try it next class. So this area here came out to 0.1587. Now, any ideas on how to get the original area we were thinking about? Think about it. What if I drew a line here? Would you agree that this piece here is 0.1587, but this whole piece from here to here is 0.9525? So if I chopped off this piece like this, wouldn't it have the area in between? You see what I did? Do you agree that that little tail there, here at negative 1.0, if I chopped it off, you'll be left with the middle? You see it? Yes or no? So what are you supposed to do when you want to find the area of the middle one? What you do is you take, and let me go back out. You take 0.9525, you take 0.1587, and you do what? You subtract. Yes, subtract them. Agreed? So that area is 0.9525, if you want to write the 00, and 0.1587. So 0.9525 minus 0.1587, it's 0.7938. 0.7938. And that would be the area in between. Does that make sense? Is this hard? But you got to print out the table and you got to do the homework and you got to try. Right? Make sense? You good? We study so we don't catch ourselves yielding to our temptations to cheat during an exam. The funny thing about being prepared is if you're prepared, you're never, ever, even if you're never going to be tempted to ever do anything that is marginal. Okay? Tell that to the kids at FIU. If you want the area in between, just I'll put it here. Just subtract the areas to the left of the z-scores. Bigger area minus smaller area. Make sense? So far, I think so. I guess I'm gonna label these as here's the first part, here's the second part, here's the third part, here's the fourth part, and here's the summary. I'll write fifth part. And this will be your summary. Now, another key to this that we have to remember that I forget is always sketch the situation. Always sketch the situation. So we're gonna do a few problems together. We're gonna do problems 21, 27, and see if there's anything interesting. I'll do 33. So we'll do 3 problems together, and maybe I should do 39. 4 problems. Do I have enough time? All right. So here's what I want you to do. Using those things, and obviously, I want you to write down the 4 problems I've underlined. Just write them down. Give yourself space, and I'm gonna leave the table on the board. And I want you to spend the next 10 minutes trying to do it based on what you just saw. So write those problems first. So we're gonna write these problems first. 21, 27, 33, and 39. Try to do them, and then I'm gonna do them, and it's gonna be recorded. So at the same time, I should put this to charge. So I'm gonna go ahead and pause this recording right now. Recording. Okay, so the first thing to do is to depict the situation. So I'm gonna depict a situation for each one of those I asked you to do. And then you could check whether you did it right or wrong. So for 21, the situation, and let me slide this over. For 21, it looks something like, you got to remember that z equals 0 is in the middle. And so like 1 is like around here. So I don't know, 1.36 is around there. I mean, roughly speaking. I mean, this doesn't have to be exact. It's a sketch. And it wants the area to the left. So that's how you sketch the situation for number 21. For number 27, the situation is to the right of 1.28. So first thing you do is you locate where 1.28 is, which is like around here, whatever. And it's to the right. They want this piece here, right? The next one is an in-between situation, right? They want you to figure out the area between a z-score of 0 and a z-score of 1.54. They want this guy here, right? And that's how you depict the situation. And the last one is not a between situation. We haven't discussed this one. But in this case, this is, I'll do this in rainbow. This one says, to the left of negative 1.28, and to the right, so to the left of negative 1.28, and to the right of 1.28. So that's how you depict the situations, how you sketch it. Now, in the case of number 21, first one. All we gotta do is just read it off the table, right? So you go to your table. So let me open my table. And in this case, you would go to 1.36. So I'm gonna go here on the video 1.36, which comes out to be 0.9131. Now, if you go to your table, 1.36, 1.30, 31, 32, 33, 34, 35, 36, 0.91, 31. 0.91, 31, as you can see on the board. And so you would go and you just write here, this is 0.9, and let me do that in a more serious color. 0.9131. And that's how you will get that answer. Not even a lot of work, not a lot of math going on here. Now the next one has a z-score of 1.28. So if we read what we get on in the table for 1.28, that would just be the area here to the left. But to find the area to the right, we're gonna do what? 1 minus the area to the left. So let me go ahead and do it here first. So 1.28 happens to be right here, 0.8997. Let's do it on the board. was 28, 20, 21, 22, 23, 24, 25, 26, 27, 28. 0.8997. 0.8997. So this area here is 0.8997, but reality, we want the area to the right. So it's going to be 1 minus 0.8997, whatever that equals to. 1 minus point, oh man, I put 11. 1 minus 0.8997. That's point, yes. 0.1003. Point.
Mr. Nami told me to give you this for the forecast grade and to give it back to him by tomorrow.
Oh,
Only on day.
okay. Oh, because that's more my students.
Yeah,
Can I just do it right now?
if you want.
You know what? I'm gonna ask them in class what they think they should get, and I'll send it over to them.
All right. Thank you,
All right.
mister.
You're welcome.
Bye.
Bye-bye. And that's it. So now we can do an in-between situation, right? I think that's a 1.54, not the best 1.54, but you know. So what we do in between is we find this one, find that one, and then we subtract them. Agreed? So first we find the area to the left of 1.54, and then we find the area to the left of 0. So what is the area to the left of 1.54? If you can see it, it's really hard to see. Zoom in a little bit more. It's 0.9382. 1.54 is 0.9382. And what's the area to the left of z equals 0? Well, that's the middle. That's going to be 0.5. Look at 0.00. We get 0.5. And now we can say that this area here is 0.9382 minus 0.9382 minus 0.5000. That's 2834. And then finally, the last one. The last one, we got to get this area, which we can read it straight off the graph. And then we find this one by taking 1 minus what we see on the graph. Now, this situation, you notice that both of them have the same z-score, but one is negative and one is positive. By the way, once you found this one, you've also found that one. You can just multiply it by 2. But if you just want to be stubborn, then go ahead and do it. In other words, what you realize is that negative 1.28 here is equivalent to positive 1.28 here. You also realize that this area here to the right of 1.28, of negative 1.28, is equivalent to the area to the left of positive 1.28. And that happens because of their mirror images of each other, because of symmetry. And so we look up negative 1.28, and be careful with the signs now, not the signs, the order. Negative 1.29, 28, 27, 26, 25. What do they want?
28.
I skipped it. They wanted this guy. What was I thinking for? 0.1003. 1.003. So this is 0.1003. And then this guy has to be 0.1003. If those two weren't the same, except for their signs, you would have to find the other one separately. You would have to find the other one separately. So we just take 0.1003 and add it to each other, right? Multiply it by 2 essentially. So you end up with 0.2006. And I think that's enough, right? Don't you think so? Yes, sir. Yeah, the area under the whole curve, Dylan, is 1. So if you know the whole thing, if the whole thing comes out to 1, and you know that from here to the left is 0.8997, and I want the tail that's left, you just take 1 and subtract that. 0.8997. That's to get the area to the right. And remember, the table only reads areas to the left. Another word for the left is cumulative area. Does it seem pretty easy? Now, next class, please have the table. I'm gonna try to have the table printed out for you. And please try that homework assignment. If not, you're gonna have time to do it in class. I'll put the answers on the board, but you won't get credit if I don't see the sketching. If I just see answers and I don't see the sketching, you won't get credit. This is to prepare you for your first quiz on normal distribution. Okay. So let's stop it there. Stop the recording there and